Okay, so lecture 10. So school called off classes today. As we voted in the beginning of class, I'll give you your content. Probably go a little bit faster. And I'll make sure it gets posted up to Brightspace as we move forward. So remember, we got student hours tomorrow between 3 and 4. I got to cancel office hours. I have to go up to Dairy to give a tour to a bunch of 4-H kids. I should be back here for the review session, run that online. Our first exam is a week from Friday. So we can have 2 full work weeks. We're at the end of that. So I put up on Brightspace some videos of Joe. Joe is the skeleton over in the rehab center. I did the basically the axial skeleton, the front leg, and the back leg. There are numbers on there. The legs. Let's see if I can get this to work. Um, so this is the one here. I filmed it pretty quick. Moving across, you can stop and pause wherever you are. So we zoom in on the front leg, scapula, humerus, um, ulna, radius, get to our carpals, our metacarpals. We've got one sesamoid up, bone on the ground, the other's on the floor there. And then our P1, P2, B3 there. So learning what those are, I thought it might be helpful to do that. Um, so where are we? Need to get back. Oh, so we're still sharing. So we've got Joe's legs there. So you've got, um, I guess I gotta stop that one. Where's the stop? Back to there. So they're there for your edification to work through. So those videos there, I'd like to take a moment to talk about how we learn. And we as human beings have the capacity to learn and move forward. The traditional way we think about learning as some scholarly individual or somebody smart is going to fill your head with all kinds of information. And it's kind of a passive approach that maybe isn't the best way, the most efficient way or productive way to learn, but it is very quick. If I stand up here and spout things that I expect you to return, there's a quick exchange of information as we go through. A better way to do it is a more active approach where you have kind of a source of that material and it's going out to a number of different individuals. It's going in and out, and there's discussion happening. There's a conversation happening between the receivers of this information where they're communicating, discussing, clarifying information back and forth. This is a more robust learning environment. It's also called an active learning environment where the receiver of knowledge is receiving information and using that, talking about it, moving it around in some way, shape, or form. Another thing that we might be able to do to study as we move forward is I posted, I think last week, some study sheets. They have the date, lecture you can go through and look at the slides I posted. What do you think are the learning objectives? Given those objectives, what are the key ideas or concepts? And then how are you going to study or remember those concepts? And what questions do you have that we need to discuss to clarify your understanding? So it's a good way to summarize the lectures. Um, I used it a lot as an undergrad, probably more so as a grad student, but taking the time to go back and reflect on the lecture and summarize things down to one page So that means by the time we get to tests, you'll only have 10 pages to study instead of all those big packets that we created or I handed out to you. So AP learning, certainly anatomy and physiology, there's a certain amount you're going to do on your own, but I recommend forming study groups to ask questions. I know certain groups have asked for clarification during the review sessions. See if you can find somebody to work with. It always generates more robust learning when we do that. So Joe is up on YouTube. I posted those links up on Brightspace. They are in our lecture resources. You have a less than 1 minute video for each of these that views his axial skeleton. You can go through and pause. So I move through pretty quick. You can pause at any time to give some thought or as to what the numbers might be, what your answers might be. I didn't post answers up on Brightspace, but if that's something you guys want, I can provide answers as well. But you should be able to, given what we presented in lecture, you should be able to find those answers in your notes. Last time we talked about bone. And one of the unique things that as a tissue, it's not just made up of cells, but also a matrix. That matrix is what we think of most of the time with bones. You have the organic component, the things that are made with carbon. You've got the proteins, the sugars, all that stuff comes together to create a scaffolding, the shape of the bone that we want. And then we backfill, or the cells backfill that organic matrix with calcium and phosphorus and the minerals in the form that they come in to make that structure rigid. So it's almost like doing a brick wall backwards. We put in the kind of the mortar first, and then we bring in the bricks later to make things rigid and have that final shape. And we talked about cells, the osteoprogenitor, which can turn into all of the other bones cells. We have the osteoblast, which builds bone, osteoclast, which clears bone, and then the osteocyte that's going to sit in that bone and put minerals in and take minerals out, which we'll discuss today. So new bone, for whatever the reason, whether we're remodeling to get rid of areas that we're not using, to build up other areas that need some help, whether we're growing or whether we're parrying a break, overview, the 30,000-foot view is the process is the same. We've got new cells. They form by splitting those osteoprogenitors into multiple cells, so mitosis. We divide and multiply, and then we get bigger. We hypertrophy. Once those cells are big enough, they're going to lay down a matrix made of protein. And then the cells are going to fill that matrix with minerals to make that matrix rigid. Protein by itself would be floppy. The minerals in there make that structure rigid and give us the bones that we're used to thinking about. That remodeling, we osteoclasts clear the bone, especially in a broken area, clean stuff out, and then we reverse it. Osteoblasts come in, they synthesize matrix, and then fill in that matrix with the minerals to give us a new section of bone. We're talking about osteocytes. We talked about the osteon, the cylinder that we're dealing with here. It's got a central blood supply where all of the nutrients come in, and then those nutrients have to diffuse through all these little squiggly lines here to get to our osteocytes, these black dots that are encased or hiding in the osteon. So it's going to take a little bit longer to get nutrition to oxygen to those cells, and it's going to take a little bit longer to get the waste products out. So that's one of the reasons that bone heals much more slowly than the rest of the body. We have to establish those structures, and then we have to bring in the materials, and that takes a little bit longer as well. So the osteons are the cortical bone or the compact bone on the outside, and that's where we're going to focus on today. So we talked about calcium homeostasis. Calcium has a number of different jobs in the body. We think mostly of the bones, but there's other things that the bones do. We need to store calcium in the body for later use. It's scarce in the environment that we're living in, scarce in the environment that the horses are living in. So when times of extra, they got to be able to put it away for later use, particularly when we're generating a fetus and we have a large transfer of calcium to that fetus, that horse or foal in utero. We need to be able to transfer the extra that we have and still maintain our own strong bones. Another thing about calcium, it's very insoluble in water, so we can't keep lots of it in the blood. The parts milligrams per deciliter is pretty low on calcium compared to our electrolytes. So if we get too much in there, it'll start to precipitate out, and that's going to cause problems. So bone serves as a reservoir for a variety of minerals. We're going to focus on calcium here. Bone tissue acts as a reservoir when calcium is needed by the rest of the body for whatever functions. Bone can take it out of the bank, the calcium bank, and provide it. If we have excess, the bone can store it for later. So we did that all last time. So regulation of hormones, calcium homeostasis, we brought this up last time. We're dealing with two hormones and one blood cell type, that or bone cell type. That bone cell type is the osteocyte. So the first hormone we'll deal with is parathyroid hormone, often abbreviated PTH. So the P, the T, and the H. The other hormone we're going to deal with is calcitonin. So these two hormones are both produced by the parathyroid gland and have opposite effects. So both came from the parathyroid gland that's on the trachea, right under your jaw. And then we have the osteocyte, is the bone cell type that responds to these two hormones. And we remember that the osteon is sitting in these little caves connecting or communicating with the other osteocytes by basically yelling down a little hole or a pipe, and we're moving what we need to. So both hormones come from the parathyroid gland. When calcium is needed, the parathyroid hormone pulls calcium from the bone. So the parathyroid senses the calcium level in the blood. If the calcium level is low, the parathyroid hormone is secreted. It's going to travel through the bloodstream into the bone tissue, diffuse out of the blood vessel, and then work its way through those small canals to get to an individual osteocyte. When the osteocyte receives that hormone, it's going to pull calcium from the bones and then send that loose calcium back to the bloodstream, and thereby increasing blood calcium. This is not a minutes thing. This is usually an hour or days thing to adjust that blood calcium. If calcium is in excess, we don't want it precipitating out. We need to put it away. So we need to send that calcium to the bone tissue, and calcitonin is going to put it away or tell the osteocyte to put it away. So calcitonin is secreted by the parathyroid in response to excess blood calcium, too much blood calcium. We need to store some for later. That calcitonin enters the bloodstream, goes through the heart, pumped out through the vessels. Those vessels, some of them will enter the osteon. Their calcitonin will diffuse out, go through the little canals, and get to the osteocyte. When the osteocyte gets that signal, it will start taking calcium out of the liquids around it and putting it back into the matrix in the little cave that it's in. So basically, plastering the walls again to save that calcium for a later time. As calcium is withdrawn by multiple osteocytes, the blood calcium is going to go down. And then we're going to save that calcium for later. So the activity of the osteocytes, their response to those two hormones is key on how we maintain our blood calcium level. So when it gets a signal, it lowers the blood calcium, it raises the blood calcium by putting stuff into the wall around it in the cave that it sits, or pulling it back out, depending on what the need is. So I want to, before we leave bones, talk a little bit about joints. So there's a lot of bones there. We're not going to get into them as individuals. There's three types of joints that we're going to deal with when we're dealing with our horses. We've got the fibrous joints. These are the spaces or connections between bones that are connected but don't move between them. So we think about the skull, the plates of the skull, whether the cranium or the facial components are connected by a seam, and we have a fibrous connection. Protein is going to make that connection. And we can also think of the pelvis as one of those. The different parts of the pelvis are going to be glued together with those fibrous joints. We have some cartilage joints or cartilaginous joints. We're going to see those in the rib cage. So the connections between the rib and the vertebrae, the rib and the sternum, the false ribs and other ribs, we're going to have something there that's got a little elasticity. We have a little movement, but we don't have a fluid kind of synovial joint, which is the next connection that we're going to get. So there's a little bit of stretching, there's a little bit of movement, but they're not huge. And we don't have an articulation or an opening or closing of a joint around those ribs. They just stretch a little as our muscles work on those. And the last joints we have are the synovial joints. Those are the ones involved in movement. So we have the cartilage at the end of the bones, and then we have some liquid there that's going to lubricate that movement, allow for a greater range of movement in those connections, so the animal can walk and move forward. So those are the three joints that we'll find between our bones. Everywhere from something that's fixed and immobile to something that's very articulated and goes through a range of motion. Types of bones, we can probably figure these out or think about these. So we've got the long bones that make up our joints as a rule. So everything from the humerus in the front all the way down to the phalanges, all the way to P3 at the end. You've got your flat bones that are associated with the ribs, skull, scapula and pelvis. We got our short or cuboidal joints in the carpals in the front and the tarsals in the back leg. We got the irregular ones that have specific reasons for their shapes, as we talked about the levers of movement, the vertebrae, and then the sesamoidal bones that are going to help move our bones and muscle and tendons around a joint. So the patella, the kneecap in the back, the navicular or sesamoids, depending on what we're calling where. Um, they're going to help with the mechanical advantage, the lever moving that joint around. So long, flat, short of cuboidal, irregular, or sesamoid bones. So while we're here talking about skeleton, I kind of want to talk about feet. So feet are pretty important. We're going to spend a lot of time caring for those, a lot of time looking at it. We do that extra thing with horses of putting shoes on their feet to try to protect those feet, to try to keep those feet oriented the way they should be, so that all the parts of the feet work in concert and don't damage each other. So with regard to feet, I can't write on the whiteboard because I'm not there, but we have two key points that I want to focus on. There's two important jobs we need to think about as riders or animal or people that are caring for our horses. One is we need to maintain the orientation of the toe bone relative to the earth. If we tilt that bone too far in either direction, bad things happen. We start to get imbalances in weight bearing, and that's going to lead to the destruction of hoof and ulcers and problems. The other thing is we need to protect the sensitive area between the toe bone and the hoof. If that area gets damaged, if that area gets punctured, if that area gets infected, a lot of bad things can happen, and we can run into also a lot of pain associated with those problems. Another thing we need to think about is the hoof grows slowly from 2 points. One is the coronary band where the hair meets the hoof coming down the leg. The other is we have some growth on that sole plate underneath. In both cases, the hoof generated is being generated about a 1/4 inch or 5 millimeters per month. And then we have those two growth points moving toward each other, and where they connect together is called the white line. So we need to protect and orient our foot depending on how we do things. And then we need to make sure that our hoof is, or know that our hoof is growing slowly, and we need to accommodate that as we go forward. So we've got the hoof, we've got the soft tissue, and the bones. Those are all part of the foot. Down there, the end of the leg. How do they all work together? What are the different functions of those parts? So we can think about the hoof of our horses as our foot in a shoe. So we've got a outer tough area that's going to represent the hoof in our horse. Then we've got the sensitive area. That's the skin and the outer parts of our foot inside that boot. That's going to represent the lamina and the corium in our horse. And then we got the bones inside that third layer in. That's just like what we have with our horse. So the bones deep inside. And our job is to make sure that this outer area remains intact, remains functional to protect those soft areas on the inside. So the hoof, we can think about it divided into 3 parts on our horses. We have the wall, which is what comes down. We have an outer and an inner. We have the white line where the wall and the sole connect. And then we have the sole underneath, kind of protecting the front side of that bottom of the foot. So we want that normal hoof wall to be smooth and shiny. It's going to be generated from the coronary band right through here, this uh, green line, and it's going to be secreted or constructed about a quarter inch a month. So it's going to hopefully every 4 months, we're going to do a inch or so of hoof. That's when we come in, at least that's what I'm hearing, and reshoe that animal. So this length here, we divide it by inches. That's going to be 4 months for every inch. Then we got the heel being generated in the back. It's uh, being worn off or taken off a little bit faster in the front. So you're going to have almost a year up front, depending on the size of the animal, and probably half that in the back of growth moving there. We want the wall to be shiny and smooth. That indicates good nutrition, and we haven't really um, damaged or put a stress on that growth tissue, the coronary band. That's so we want that constant in thickness. So the wall is the hard surface on the vertical section of the hoof exposed to the environment. It's produced from that coronary band. I think I've seen coronet band. The idea behind that is crown, the root word for crown, the crown on the top of the hoof. So it's the hoof skin junction, and we're going to travel down the lamella or uh, lamina a quarter inch a month. So we're looking at our coronary band up here producing that hoof. We hope we have something strong enough that's going to support the weight of the animal. So you have basically these two cylinders that the animal's going to walk on. This outer wall is what we attach to the horseshoe, and that's going to bear the weight of that animal. So we need it balanced. We need strong. We have what here you can see it's like kind of growth rings on a tree coming down. This, on some level, might be considered a hardship groove. If for whatever reason we're not getting the nutrition that we need, or the animal is sick, or has acidosis and has inflammation down here, we're going to have less of a thick wall in this area over here. And that forms a groove in that hoof as it comes down. So this area is thinner than maybe the areas above and below. So this kind of creates a rough section that's not as strong as the other areas. You can see the cutaway over here, that this area is not as thick as these areas down here. We've got what's called a hardship groove. If you want to really impress somebody, you see in a hardship groove, you figure out how many inches back that was. If it's an inch and a half, quarter inch a month, you say, hey, what happened to this animal last summer or 6 months ago? And you're like, well, how'd you know that? The animal was compromised in some way with this hardship groove on this animal. So you've got two layers to the lamina here. You've got this part that's attached to the bone and the part that's attached to the hoof. So the sensitive and insensitive areas, sensitive to the bone, probably has all the nerve endings. The other end here doesn't have the nerve endings. You're just connected there. That's kind of a new terminology for me. But we have that. We have the sole. It's kind of concave. We want the weight bearing on the wall. So if we're looking at our hoof here, we have the outer wall where our shoe is attached. That's where we want to bear the weight. We're not going to be bearing a lot of weight on this sole. runs from here to here. Should be concave. It's not necessarily flat, but it provides a certain amount of protection to the sensitive tissues underneath. So if that animal's moving, we need to have that intact to carry that out. So the sole is the exposed area at the base of the foot. It separates the wall. It's separate from the wall, is produced by the corium underneath. So instead of creating like the wall does, something tall and thin, this creates kind of a plate there on the bottom of the foot, and it grows at the same speed as the hoof wall does. And that's important when we get to the white line. So we have the wall coming down 1/4 inch a month, and then we're having the sole produced at 1/4 inch a month here. And then we knit those two things together in this yellow section here, the yellowish line there, that is that seam there. And then we've got the two layers. The outer wall is a little darker than the inner wall, a little whiter. And then inside that is our white line. This is going to be the weak spot of our hoof. If we don't have an animal that's unshoed going over rocky ground, or there's rocks in our cement floors or anything like that, what's going to give way first is this white line. And that's not something we want, because that exposes the sensitive tissue underneath to damage, infection, bacteria. None of those things are good. So that white line is the weak spot there. Point of weakness and a common place or common area for working through on our unshoed animals. They might get stones penetrating through that break. So wherever that white line is, that's our break. So factors that'll determine hoof quality: certainly the genetics of the animal. How thick or how well does that animal create hoof? Is she better or worse than another genetic line? The environment is going to influence the quality. If we're exposed to wet, mud, all that stuff, that's going to lead to a weakening of that hoof, a weakening of that protein. And as it weakens, it can be exposed to bacterial damage and get into trouble that way. Certainly things related to nutrition. Are we getting the calories that we need? Are we getting the amino acids that we need to build good hoof? Do we have all the micronutrients that are necessary to build a good hoof? The vitamins and minerals. I'm thinking probably copper. We've got biotin. What else is there? A couple other vitamins that are directly associated with good quality protein, building up our hoof the way we have. And then our management. How often do we ride? How good is that shoe put on? What kind of stresses are we putting on that animal? That hoof is a protein base, so it's not going to be designed to handle extremes in stress. We can certainly grind that down pretty quick. We can make that collapse or be unhealthy fairly quick. I appear to have jumped ahead here. Hold on. What happened to my PowerPoint? Okay, so so we got the parts of the hoof. Next up is the soft tissues on the inside. So going back to sharing. I don't know why we jumped all the way to the end. Sorry about this. Okay, so soft tissue. Again, we're talking about that red line. It's basically the skin that we stick inside a boot. So the lamina or corium is a soft support tissue that carries the nerves, the blood vessels, and transports the nutrients both to the hoof and to the bone. So we have this space between a hard hoof and the hard bone where everything moves and is transported through. We have our blood vessels, we have our nerves, and we have our nutrition. So those two sensitive pieces are going to provide support. We'll talk about that in a minute. They're going to provide nutrients and they're going to provide sensory input to the world around that horse. So what are we stepping on? If pain is experienced when this soft tissue is compressed, penetrated, or infected, just like when you hit your finger with a hammer, you've got the shell, the nail on the outside. We that represents our hoof. We got the underside is our corium, and we blow a blood vessel hitting it with that hammer. We need to relieve that pressure, usually by puncturing through the nail, through the hoof, to relieve that pressure for our animals. So we're looking at on our animal here, we got the lamina on the side here, and then we got the sole or corium down here below. So we have on the front side, we have all the blood vessels, all the nerves coming down, providing that sensory input, providing both nutrition in the corium band for that, anything that we need in here, and also a blood vessel comes down and enters the coffin bone and provides nutrition and waste management for the coffin bone. We got the same thing coming underneath. We have the corium underneath here that is going to produce the sole. So we need building blocks, amino acids, energy, carbohydrates, fat to run that process. So we lay down that sole. So we don't want to compress or have problems there. That's going to cause problems. We're also dealing with a digital cushion in here, back in the frog area, that's going to help that animal absorb shocks and hopefully help that animal walk a little easier. So that digital cushion is made up of fat. So as our animals get too skinning, this digital cushion can be something that disappears. But that sensitive tissue, again, you've got the difference between the bone, the end of the bone. In this case, we're calling the pedal bone, coffin bone, the P3. That space between, we need to protect that at all costs, making sure that nothing comes up, penetrates. We don't jam a foreign object in there that leads to this getting infected. Because if there's any swelling or immune response there, you're going to be pressed between the hard bone and the hard hoof, and that's going to lead to a lot of pain, just like when we hit our thumb with a hammer. So we need to protect that at all costs. Bones, we've been over these already. So we've got the two sesamoid bones at the end. We have the medial and lateral sesamoid up here. We've got the three supporting bones, the proximal phalanx or long pastern bone, middle phalanx or short pastern bone, and then the digital phalanx or coffin bone or P3 or toe bone, whatever you want to call that. And then we got our navicular or distal sesamoid bone in the back there. So looking at an X-ray kind of thing, you can see our sesamoid bone back here, long, short coffin bone, and that funicular or sesamoid bone in there. Again, we're showing that suspension of our bones in the hoof. The bone does not directly touch the hoof. If we look at this diagram, we talk about that. We have connective tissue connecting the hoof and reaching over little thin threads that are going to hold up that toe bone inside the hoof. So down here, we've got pieces that are going to hold that up. We got pieces that are going to hold that up and keep the toe bone from coming in contact with the hoof. So we can think about it as a web or a suspension system that's going to hold that toe bone up and keep it at the correct orientation. If we stretch that connective tissue, particularly up here, by not keeping our hooves trimmed, we start to tilt back. We put excess weight on that connective tissue. It's going to start to fall down as it stretches. And as it stretches and this falls, it's going to compress this lower corium, and that's going to cause pain. That's going to cause injury. It's also going to retard the blood flow so our sole does not form the way it should, because it's not the growth tissue there for the sole is not getting provided the nutrients and oxygen it needs. And then you start to get toe ulcers and things like that. So we want to make sure that these are well suspended, well taken care of, and don't ever touch the bone to hoof. If the bone touches the hoof, we tend to force that bone through, and that's not going to be a good day at the end of it all. So we have our bones down there. Which parts are we going to ask you to remember? So we got three sesamoid bones, three toe bones that I want you to remember. What is their purpose? They are going to hold things up. They are going to actuate the movement. We've got the wall hoof parts. We got the wall. We got the white line. We got the sole. We got the coronary band. We got two tendons that we haven't talked about. We'll have to talk about next time. We got the lamina on the sides of the hoof. We got the corium underneath the toe bone. We got the digital cushion and the frog. Those are the parts I want you to remember. Those are the ones you'll be tested on. That's where I'll stop today. I'll get this posted over the next hour. If anybody needs to look at it again, or anybody wants to review things. Before I go, any questions for those of you that showed up for this? Okay, we'll call that a day, and we'll get this posted to our website, and then the YouTube video should be up on Brightspace within the hour. We'll see you.